A plane is flying 500 meters overhead when it drops a crate full of supplies to the people below. The plane was moving 85 meters when the cargo was dropped. How far before the intended drop zone should the plane release the cargo? We have our picture drawn. Here's my plane. All the numbers in black are going to be the X or left-right numbers. All the numbers in red are going to be the up and down or Y numbers. So we can see the velocity in the X direction is 85 meters per second. We know the velocity in the X direction is a constant velocity, so that's not going to change. Those arrows are the same size, not getting slower, not getting faster, going left and right. In the Y direction, the acceleration is negative 9.8 meters per second squared, and we know it's going to fall 500 meters. The question mark is how far before should we drop it, so that's the displacement in the X direction. So now we're going to plug some numbers in. First, in the X direction, D is the question mark, and we know the velocity in our picture, 85 meters per second. In the Y direction, the displacement is downward, so negative 500 meters. The initial velocity in the Y is 0 because the plane is flying horizontally, so the package or cargo does not have any initial upward or downward velocity. The acceleration, negative 9.8, because everything in midair has an acceleration of negative 9.8 meters per second squared, at least everything that we're talking about in this section. And there we go. We do not have enough information in the X direction to solve for the displacement straight away. We would need time. So we're going to solve for time in the Y direction, use it in the X direction to get the thing that we're really looking for. I don't have final velocity, so I'm going to use the equation that doesn't have final velocity in it. That would be D equals V naught T plus 1/2 AT squared. Solving for time in this equation can be a little bit of a bear, but what's nice is initial velocity is 0, so that term cancels. That makes our math a whole lot easier. D equals 1/2 AT squared. Solving for time, I'm going to multiply by 2 to get rid of the half and divide the A over. So that gives me 2D over A equals T squared. But I don't want T squared, I just want T. So to get rid of the T squared part, I do the square root like so. Now I can plug in some numbers and solve. So that would be 2 times the D is negative 500 all over negative 9.8. And all that is under a square root symbol. And when I plug that into my calculator, I should get a time of 10.1 seconds. Now, that means that in the X direction, it's got 10.1 seconds to get to the ground. So that's how far it's going to be able to travel, is the amount of distance it can travel in 10.1 seconds. So now I'm going to solve in the X direction. That's constant velocity motion in the left and right. So I can use very simply D equals V times T. Our velocity, as we said, was 85 meters per second, and our time was 10.1 seconds. And when we plug all that into our calculator, we should get 858.5 meters when we kept all those digits.